Welcome to this iconic CNC training video. I'm your host, Steve Stevenson. In this video, we're going to focus on ArtCAM Standard. We're going to look at some of the basic 2 and 2.5D functionality of ArtCAM Standard. We're also going to look at how to import and create a machining toolpath with a 3D model. Now, unlike its predecessor, or the software that we at one time provided with our iconic machines, ArtCAM Express, ArtCAM Standard does have 3D functionality, so you can design your own 3D models. We're not going to focus on that in this training video. In this series, we're going to look at some of the 2 and 2.5D functionality, so it's more geared towards someone who's learning CAD design software for the first time, or you're perhaps reacclimating yourself to CAD software. So we're going to kind of give you some basic boot camp instructions, if you will, on how to use some of the functions and features of ArtCAM Standard. So I'm going to first double click on the ArtCAM Standard icon on my desktop. And you can see when the screen opens up, the nice thing about the Autodesk ArtCAM interface is that you've got some training videos, some additional training videos in addition to what we're providing you with that you can draw on right from inside the software. So there's always opportunities to learn more. Well, our recommendation is the basic training that we're providing will provide you with basic function in 2 and 2.5D, and then you'll find that there is a host of Autodesk resources available that will teach you all sorts of other functions of the software, including how to design your own 3D models. For example, if looking at this creating relief model here, those training videos will teach you how to do that sort of thing. So in this case, we're going to go up here to the top, and you see the option that we have is to open a new model. We can also open an existing project that we've been working on. In this case, we're going to click on New Model. And the first screen that's going to pop up is our dimension screen. So it's going to allow us to establish the size of our workspace. Now, it's important to understand that this is the workpiece that you're actually going to be installing into the machine. It's not the bed size, it's not the machine's capacity, and it's not what perhaps the final project would look like. In some cases, you may be cutting a final project out. So it's the actual piece of material that you're going to be mounting inside the CNC machine before you start machining. So, and you'll also notice that as I change these dimensions, if I change the width, the little illustration here on the right changes proportionately. So I'm actually going to leave that material size as it was at 12 inches by 12 inches. You'll notice there's a slide bar here for resolution. So resolution basically is measuring the number of points that will be established if, and it really only relates to if we're designing a 3D model. In this particular case, we're not doing that. We're going to be working in 2D. So the resolution really isn't quite as important. But as a general rule of thumb, I keep it somewhere in the middle of this slide bar. That's somewhere around 1,000 by 1,000 points. And that creates a pretty significant amount of detail in our 3D models. But you can certainly set it to a higher number if you want a really fine detailed resolution. But do remember it does draw on system resources on your computer, so you may find the refresh rate on your computer slows down a little bit if you get the resolution super high. And you also see that we have the units in either inches or millimeters. In this case, I'm going to work in inches. And then the last thing is the origin, the job origin. So right now you see I have it set at the top left corner, but by very simply clicking on any one of the other corners or in the center, I can change that origin position. Now on the iconic machine, the home position for our machine is actually top left corner. So as a general rule of thumb, most of the projects that I do, I will use the top left corner as my origin position, because if I mount my material on my table, the top left corner has already been established. So I already have the workpiece right where I want it to be. I can send the machine to the home position, and my X and Y coordinates are essentially already zeroed. So I'm going to use the top left corner in this particular case, and I'm going to click OK. And you can see that we have our workspace here. In 3D, we have the option of clicking on either the 2D or the 3D view. In this case, I'm going to work in the 2D view. I tend to use the 2D view for doing all of my vector creation. So as I'm working at designing my image, I tend to work in the 2D view. You can actually do it in the 3D view as well, but I find that sometimes you'll have simulations that you've created as you're sort of examining your project as you go along, and I find there's just a little bit too much on the screen for me. So the 2D view basically only gives me the vectors, and you'll see as we go along what all that means. But I just find the 2D view a little less confusing when I'm working on designing a project. Now, if you look down the left-hand side, you see there's several different tools that we can make use of. And also across the top, there's also lots more tools. And we're going to look at some of these tools as we go along. Now, a couple of things you'll make note of. First of all, you'll notice as I move my cursor over each one of these tools, we get a little flyout that basically is going to tell us what that particular tool is about to do. The other thing you're going to notice is that these tools are divided into sections. You see these little grayed lines in here. This actually is a toolbar that I can actually grab and drag out of the sort of the main menu. So this was a relief editing toolbar. I could take this one, bring it over here. So it's kind of nice that you can customize your screen to look exactly the way you want it. The concern that you may have, and one of the things you have to be conscious of, is that you notice there's a little X in the corner, and we all know what that means. If I click on that, I can actually delete these, which I may want to do if it's a toolbar that I'm not using very often, and maybe I just don't want it on my screen, to eliminate a little bit of clutter. This project pane, for example, you'll notice this project pane over here on the right. I could close that as well. Now, sometimes I'll do that on purpose. Other times it just happens inadvertently that I've clicked on something and it's disappeared. If I know what it is, it's very easy to recover it. I just go up into the top right corner into this gray area here, right click. You can see here where it's showing me the project pane is not visible. I can reestablish the project pane by just clicking on it. The other thing that I have to be careful of is in some cases I may not even remember what those tool bars were, and so I may be looking for a tool and have no idea where I would find it. If that ever happens, there's a very simple way to reset your screen. So you just click on Window, click on Reset Layout, and what it will do is it will reestablish the screen exactly the way it was when we first opened it up. Now, last thing you'll notice is that some of these tools, the icons actually have little arrows in the bottom right corner, and that's an indication that there are several functions or features within that specific tool that are a little bit different. For example, if you look at this tool here called the two-rail sweep, if I push and hold my left mouse button, you'll see that there are 4 different sort of iterations of this particular tool. Here's a two-rail sweep, here's an extrude, here's a spin, and here's a turn. So those are 4 different types of operations that can be done, somewhat similar but a little bit distinctly different. Over here on the left-hand side, for example, if you look at create circles, if I push and hold my left mouse button, I have either to create a circle or the option of creating an ellipse. So again, similar functions, but a little different enough that it provides 2 different operations. And you'll notice that it changed my icon from a circle to an ellipse. Whatever the last tool that I selected, that's what will appear in my toolbar. All right, so we've kind of looked at the sort of the overview of the software. So let's start looking at the use of some of the tools in 2D. So the first thing we're going to do, and you notice I've opened up my create circle tool there. First thing we're going to do is we're going to start with create a rectangle. So if I click on the create rectangle icon, you'll notice over on the right hand side a dialog box is going to pop up with basically an opportunity for us to set the parameters of this rectangle that we want to create. So I'm going to click on square as opposed to rectangle, and I'm going to set my width at 8 inches, and you'll notice it obviously by default changes the height to 8 inches because it is a square. But you'll notice also it by default wants to put this square in the center of the workspace. Now I don't have to have it there. You'll notice here's the center point being at x6 and y minus 6. It should be pointed out the reason for the y minus 6 is because of the fact that we set our origin position up in the top left corner. All of our y coordinates become negative numbers. So think of a grid or a graph. So your top left corner is x plus y plus, and the bottom left would be x plus y minus, and so on the 4 quadrants. So we're working down in the bottom right quadrant. That's why our y-axis is a minus coordinate. So you see we've got basically a highlighted area that's showing us where we're about to create our square. And if we're satisfied with that, we click create, and you can see that there's our square. Now notice that it is highlighted in red, or I was once made aware of the fact that this was actually magenta. You know, so if you see it in red or magenta, that's an indication that you've actually selected that particular object. Actually, let's close the vector creation window. If you click off of it, it will turn black. which means it's not selected. And to reselect it, just click on it. Now, also notice that with a vector, there's nothing in the middle. So if you try to click on the center of a vector, nothing exists there. The only thing that actually exists is the line itself. So if you want to select a vector, you need to select the actual, you have to click right on the line. All right, so we've created a rectangle, or a square in this case. The next thing we're going to do is we're going to look at creating a circle. I'm going to click on the circle, and you again see that the dialog box opens up on the right. Now, I'm not going to use that dialog box. I'm just going to kind of freehand draw a circle, but I want you to notice a couple of things about my cursor. As I move my cursor, you see right now there's a set of crosshairs on my cursor. As I move my cursor near this line, and as soon as I get close to it, you'll see that it locks onto that line. You're going to see that it changes to an arrow. What that means is that if I start to draw a circle right now, so if I push my left mouse button down and start to draw the circle, it's locking that center of that circle onto that line. And to delete, I'm just going to hit the delete key on my keyboard. I'm going to draw a circle again. Only this time, you'll see we know what that means. Let's just take a look at what happens when we get to around here. So you see again the cursor changes dynamically again. This is now indicating that it is basically locked onto the center of this particular vector, or that line. So from one corner to the next, the dead center of those 2 points is right there. So now if I push the left mouse button down and draw the circle, it's locking it onto not only the line but dead center on the line. And again, I can right click to complete that operation. So let's delete that. The last thing we're going to look at, I'm going to create circle. I'm going to go up here to the corner, and you see this time it changes one more time. You sort of have this set of crosshairs with a square in the middle. That's indicating it's now locked onto the corner. So now as I try to draw my circle, it's doing so with the center of that circle locked onto the corner. So we're going to draw it to about that size, and we're going to right click, and that now creates our circle. Now notice I didn't specify the size of the circle like I did with the square. Now I have the option of going over here using what's called the transform tool. This is a very highly used tool, so you'll want to get familiar with its location. The transform tool has several different functions, the most significant of which, at least for our purposes right now, is that it allows us to change the scale and the size of our circle. So you see I've got the circle selected, so whatever I have selected, that's what it's giving me the information on. For example, if I changed to the square, it would just let you see this. You will see that it gives me the scale and size of the square. So it's whatever I happen to have selected at that time. So I've selected the circle, and you can see that our width is basically almost just a little under 3 inches. And you'll also notice that there's something called a maintain aspect ratio. So this is a lock that I can turn on and off. With the lock on, if I change the width to 2 inches, it'll automatically change the height proportionately. If I took that lock off, it would not change the height. So it would no longer be a circle, it would be an ellipse. And I'm going to click apply. Now you notice the same tool, this transform tool, also has the ability to change the origin position of the vector, to move it a specific distance along the X or the Y coordinate. Allows me to rotate the object a certain degree, either clockwise or counterclockwise. And also I can shear it or change its sort of its aspect ratio, kind of distort it a little bit if I might. So I have changed my circle to 2 inches. And I'm now going to close the transform tool, and you see I've created the circle on the corner at 2 inches. The next tool we're going to look at is a tool called create polyline. It's just a fancy term for drawing a line. So I'm going to click on create a polyline. Now I want you to notice there are 2 different ways that this tool works. I'm going to start over here to the left of my square, but still within my workspace. I'm going to push my left mouse button down. Now with my left mouse button held down, I begin to drag the mouse across my workspace. And you see wherever I drag the mouse, it's basically as if I've put a piece of paper down and I put a pen on the piece of paper and I never lifted the pen up. Wherever the pen goes, it's going to draw a line. To be honest with you, I'm not sure what you'd ever use that tool for other than maybe draw your own name or write your own name. Because typically it's not accurate enough to, to maybe create a profile around something because it's just a freehand tool. Now, I'm going to use the same tool, but I'm going to use it in a very different manner now. I'm going to click on Create Polyline. I'm going to go to the same start point, or approximately the same start point. I'm going to click my left mouse button to establish the start point of this line. But this time, I'm not holding down the left mouse button. All I'm doing is moving the mouse. Without that mouse button held down, the tool responds very differently. Now it's waiting for us to establish where the next point is. Now, I had mentioned earlier that when you're using tools in ArtCAM, you'll see differences in the cursor. That's an indication something just took place here. So I want you to notice right there, you see how the cursor changed. It's indicating that we are now locked onto the horizontal line. If I left click, I've now created a perfect horizontal line across the 0 plane. Now you'll notice that as I move my cursor down, it would now allow me to create other points. So I could create any geometric shape that I want. But in this case, all I want is the line. So to complete the operation, all I need to do is right click and it will now finish that operation and establish that line for me. So it's left click to start, left click to change to select the next point, and then right click to complete it. And then lastly, I want to center this line in the middle of my workspace. So I use the F9 key on my keyboard. F9 is a shortcut key for center and model, and I've pushed F9, and that's now centered my object in the middle of my workspace. Now, the next thing I want to do is exactly the same thing, only on the vertical plane. So I'm going to start at the top, left click to start. Same thing happens when I get locked onto the vertical plane. You'll see the cursor change. I left click to create my next point. I right click to complete the operation. F9 key on my keyboard, while it's still selected, will now center it. So we've created all this geometry. Now what we want to do is we want to start using another tool called a trim tool. Now the trim tool is over here on the left hand side. You can see it down in the very corner. And the trim tool is quite unique in that it gives us the ability to trim away pieces of this, some of these vectors that we perhaps don't want. Now, you notice when I clicked on it, there's a option up here to auto join. This will probably be the last time that you don't use the auto join function. What the auto join function does is as we trim vectors away, whatever vectors remain are going to be reconnected for us. And that's a good thing, because as you'll see later on in this video, we always want to try to create a situation where vectors are closed and connected together. Now you'll see that my cursor has now turned into a pair of scissors. Watch what happens when I move my scissors over a line. See how they open up. This now indicates that we're locked onto that line. So if I left click, it will actually trim away these vectors between wherever there's an intersecting point. So what I'm going to do is I'm going to trim away all these vectors. And what I want you to have left, if you're following along this video, is this top left corner with an inverted corner like that. And once I'm done, I can close this tool. Now, you'll notice that each of these vectors are independent of each other. Because we didn't auto join them, each one is separate. And you'll see why we did that. We're actually going to look at using a different tool here shortly. So what I want to do now is I want to drag my mouse over all three of these. So you'll notice I left click to drag my mouse. Whatever's completely inside of my square or inside of my bounding box is going to be selected. Now there's a couple of ways you can use that tool, by the way. If I drag my mouse over just this far, you'll notice that all three vectors are inside the box, but the one of them isn't fully inside the box. So in that case, it's only going to select the two. There is another way to use this tool. If I start from the bottom right and start to drag my mouse up, you'll see that any time I create a bounding box, anything that's even making contact with this bounding box would then be selected. So it depends on whether you start from the left or start from the right as to how that tool is going to respond. So I'm going to use a tool called a Mirror Objects tool. You see it over here on the left hand side. If I click on Mirror Objects, you see this tool gives us a few options. So basically what I want to do is I want to recreate this object on the right hand side, but maintaining the one that I have. So in that window, as you'll notice at the bottom, there are two options. One of them is to copy the original object. So in other words, I'm going to keep this one. I want one just like it to the right. So I'm going to have that checked off. You notice there's another option, just like we had in the last tool we looked at, the Trim Vectors tool, that it's to join mirrored objects together. Normally, we would choose that. In this case, we're not going to. And this may be the last time you ever don't do that. And what we'll want to do is we want to mirror this object to the right. So you see we now have a left and a right side that are exactly the same. Now I'm going to drag my mouse with that tool still open. I'm going to drag my mouse over all of our vectors, and I'm going to mirror both of those to the bottom. So we can close this tool. So what we now have created is this geometric shape, this rectangle with the inverted corners. But I want you to notice that every one of these vectors is independent of each other. Now, if we were doing an architectural drawing of a house, this would be perfectly appropriate. Normally, if you're doing architectural drawings, you want to have all your vectors disconnected. In our case, that's not what we're looking for. What we want to do is we want to have our vectors connected together so we have a continuous machining line. If I was going to machine this right now, for example, let's say I wanted to profile this line. I would start with this start point. The machine would come in, it would machine this line, then the tool would lift back out. Then it would go back in and machine this line, then lift back out, because it doesn't understand. We look at this and see these vectors connected. The software does not. The software sees each one independent of each other. So we want to have these closed as a continuous vector. So what I'm going to do is I'm going to drag my mouse over all of these. And by there's several other ways you can do that. You can drag your mouse over all of the objects. You can also use the Control and the letter A on your keyboard. That's a shortcut, window shortcut key for select all. And then the third option is you could click on one and hold down your shift key, click on another, and then another, and so on. That's a long way to do that. If you're only selecting a couple of objects, it's kind of handy, but in this case, we want all of these objects to be selected. So I drag my mouse over all of them, and you see that I have all the objects selected. So we're going to look at a tool, and I'm going to go down here to the bottom left corner, and you can see that I have more tools down the left-hand side than you can actually see. I have to push this little arrow here, and you can see that I have options to join vectors. Now, you'll see that 3 of the options in the join vectors are grayed out. One is join vectors with a line, one is join vectors with a curve, the other one is join vectors by moving 2 points to a common end. The reason that those are not available to me is because they are only used in a situation where you have 2 vectors. And in this case, we have 12, and so those tools are no longer available. But there is one called joining vectors with coincident nodes. I'm going to click on that. And you can see as the window opens up, there are some settings that we look at. And so essentially what join vectors with coincident nodes is saying is that within a specific tolerance, in this case 50 thousandths of an inch, it's going to join all of the vectors that it sees within that distance. So anything that's 50 thousandths of an inch or closer, it's going to join. Anything that's more than 50 thousandths of an inch, it's not going to join. As a general rule, I like to start this number low. So I'm going to move this down to 1/1000th of an inch. And you can see at 1/1000th of an inch, it's going to join all 12 of these vectors so that when we're done, there's only one vector remaining. Now, that doesn't always happen that way. We'd like to think it's a perfect world, but it's not. I'm going to just grab this top section of vectors. I'm going to move it away just a little bit. Now if you watch, when I drag my mouse over all of these, it's saying that the number of vectors now is 12. The number of vectors after we're done is 2. That's not acceptable for me. I want 1 vector when we're done. So the way for me to be able to make that happen is to adjust this tolerance. So let's put this back to the 50,000 and see if that changes anything. You see it did not. So let's go a little higher. Maybe we'll go to 75 thousandths of an inch. So you see at 75 thousandths of an inch, this has now changed. And now the current number of vectors is 12. The number of vectors afterwards is 1. So now if I click join, it's now joined all of those vectors together. So if I deselect and reselect, you'll see now when I click on it, when I get one, I get them all because all of them are now one object. So now if I was going to create a profile toolpath for this object, the tool would go in here at the green start point. It would machine all the way around, come back out at the same point that it entered. So it's going to be a much cleaner, more efficient machining operation. All right, so we've created our basic shape. Now the next thing we want to do is we want to go to our text tool. So we click on Create Vector Text. Now, in the vector text section, you're going to see if I hit the drop down for our fonts, you'll see that we have several fonts at our disposal. In fact, there's quite a number of them. In some cases, you'll have hundreds. It's going to virtually download every font that's available on your particular computer. So if you have Adobe Illustrator, Photoshop, Google SketchUp, CorelDRAW, all of the fonts available in all of those programs, Microsoft Office, all of those fonts from all those programs are going to be available to you, which may or may not be a good thing. The good news is you have all those fonts available to you. The bad news is there's an awful lot to choose from, so the question would be which ones work and which ones don't. You will find that as a general rule, most fonts tend to work quite well, but a couple of things to consider when selecting fonts. One is try to make sure you pick something that's actually readable. Try not to pick a font that's very decorative but very difficult to read once machined. The second thing to consider is you want to stay away from vectors, fonts that have, think of a cursive line of text where you've got text where the letters are sort of overlapping. That can be quite problematic when we're creating machining toolpath. It's not that you can't do it, it's just a little bit more work. You're going to have to go in and edit those letters and basically reconnect them, much like we did in that last exercise. Now, one of the good things that ArtCAM has done is that they have created these fonts that are actually specifically designed for machining applications like what we're doing here. And you'll note that there's the letter A, which represents the ArtCAM or Autodesk ArtCAM logo. You'll see it's the same as the letter A up here in the top left corner. These are all fonts that have been sort of tried and true, tested for these applications. So I'm going to pick one called Banknote, because you can see it's a very heavy font. I tend to stick with fonts that are a little bit heavier, maybe bold type fonts, and very structured, much like what you see here, because I know that when I machine that, it's going to be readable. So I'm going to select that font, and you can see that I've got my font size set at 1 inch, and I don't really care what the start of the size is because I can always edit it to the size that I want later. But I want you to notice that as I'm preparing to start typing in my text, you see that my cursor is actually locked onto our object here, our vector shape that we created. And I'll explain the reason for that. Because I had selected that vector prior to selecting the text tool, essentially what I've told the software is, I want you to type the text along this curve. And so you'll see that as I start typing letters, that's exactly what it does. And that may or may not be what I was intending to do. If it wasn't, then there's a simple way to solve that. And I'm just going to close the text tool just quickly here. You'll notice right now that vector is selected. I'm going to deselect it so there is no vector selected. I'm going to click on the text tool. Using the same font and the same size, watch what happens this time. Wherever I click on the workspace with my cursor, that's going to identify where the start point of my line of text is. So I could type in Iconic CNC and create that. Now, you can see it's too big and it's not positioned correctly, but that's easily fixed using our transform tool once again. We're going to change our width, so I know I have an 8-inch rectangle, so I'm going to change my width size to 7 inches, and with my maintained aspect ratio lock on, my height proportionately changes. I'm going to click apply, and then very simply I'm going to use the F9 key on my keyboard to center my object in the workspace, and then I'm going to close my transform tool. So I've created a line of text, I've created our vector box. Now what we want to do is start looking at toolpathing strategies. So if I click on toolpaths, you see in my project pane I have several options here. I'm going to click on toolpaths. When I click on the toolpaths tab, it's going to open up our toolpathing operations. I want to focus on the 2D toolpathing operations, and specifically I want to look at 3. The first one is called the profile toolpath. So if I click on this rectangle, supposing that I wanted to machine basically this shape and all of the outside piece here was going to be scrap material. And so I'm going to create a plaque or a sign with this square with the inverted corners. I could use the profile toolpath if my material thickness was 3/4 of an inch. When I click on the profile toolpath, you'll see when it pops up, it gives us the option to set our start depth at 0 and our finish depth. I would probably set it at like 0.677 or 0.78 if I had a 3/4 inch piece of material. I want to make sure I cut all the way through, so I'm going to cut that piece out using a profile toolpath. And you see where it says click to select. I'm going to select probably an end mill, something appropriate for doing cutting operations. Supposing that I was doing the opposite. Supposing I'm making a picture frame. So this becomes my material and this is my waste in the center. It would be the same profile toolpath. I would just change it from the inside of the line to the outside of the line. And you see right here we have those options available to us. The last option might be I want to create a decorative border. So I'm going to machine my line of text and create a decorative border around this. If that's the case, then I would still use a profile toolpath, but in this case I would select along the line, and now my start depth might be 0, but my finish depth may only be something like maybe 0.125 or 0.0625, depending on how deep I want to create that decorative border. So you can see that there's 3 different operations, very distinct from each other, but it's the same profiling toolpath. It's just a question of which tool we select and how deep we want to machine. The second one I want to look at is called an area clearance toolpath. So if I click on the rectangle with the inverted corners again, and I use an area clearance toolpath, what it's going to do to whatever depth we request, it's going to set our start depth, say, at 0. Let's say if we put our finish depth at 1/8 of an inch, it's going to basically pocket out or do an area clearance to an 1/8 inch depth in this area here. Now, if I were to select two objects, so with my Shift key held down, I select both the outside rectangle and the line of text. Now what it's going to do, the software is going to machine inside this rectangle, but it's going to leave this word iconic CNC unmachined. So, and you could have several objects here. We could have a circle up here. We could have a square down here. If they're all selected, it's going to machine inside the outer object, but it's not going to machine the inner objects. But you'll see some limitations on that in just a couple of minutes. But it is a very good tool for doing, for example, if you want to pocket out something for a coaster or to dish something out, you will find that the area clearance toolpath is a pretty handy tool to use. The next one I want to look at is one called a Debit carving toolpath, and it's a really unique tool. And it's something that's quite unique to the Autodesk ArtCAM product line. Now let's zoom in on one of our letters. Let's zoom in on the letter C here. And I want to focus on this corner specifically right here. So let's say that we wanted to machine out the inside of this C. So we're going to do an area clearance in the middle of the C. So we want to cut out, and we'll do the same thing with all these other letters. So I'm going to select a circle, and I'm just going to draw a circle that will represent our diameter of our tool. So let's just set this at 0.0625 radius or thereabouts. That's just approximate. So this is approximately a 1/8 inch. This circle represents the diameter of an 1/8 inch tool. And we're going to create that. And it's not exact, but for our purposes, it's not going to matter. So I'm going to select the circle, and I'm going to just, using the directional keys on my keyboard, so I'm just using the left, right, up, down keys on my keyboard to move this circle where I want it. Which is a pretty handy tool in ArtCAM, by the way. And I'm going to tuck it up into the corner. So as you can see, we have a problem in that this tool can't fit into the corner, so we don't get the square geometry. And that's a problem. So an area clearance toolpath in this particular case is not a functional toolpath for us. It's not going to do what we want it to do. So let me just get rid of all these circles that I've created. So let's zoom back out for a second. I want to again focus on this corner. So what the V-bit carving toolpath does is it recognizes the square geometry, and it uses a V-bit. So think of a 90-degree V-bit or a 60-degree V-bit. It's going to recognize this corner, and the tool is essentially going to swoop out of the corner and then swoop back in. And as it does it, it's going to create this square geometry. So for the purposes of cutting things like text or logos or line drawings or something where you want to reproduce the geometry exactly as you see it, then the the V-bit carving toolpath is an excellent choice. So all that said, let's start first of all with our rectangle. We're going to use a profile toolpath, and what I want to do with this is I want to just basically create a decorative border around. So this is going to be a 12 by 12 sign, and we're going to create a little decorative border around it. So you can see that the profile option is outside, inside, or along. I'm going to select along, so the center of my tool is going to sit dead center on the middle of my line. My start depth would be 0, which is the top of my material, and I'm going to set my finish depth, not very deep. I'm going to set it at 0.0625, a 1/16 of an inch essentially, is all we're going to machine into this. The tolerance, you really don't ever have to change. It should by default be set at 1/1000th of an inch, as you see it is on my screen. And all the tolerance is recognizing is whenever it sees radiuses like this, it's not going to allow the tool to move more than 1/1000th of an inch off of that radius. So as it's creating its toolpath to go around here, every one of those points in the toolpath is going to be within 1/1000th of an inch, which means your radius is going to be nice and smooth. So you don't really have to change the tolerance. Lastly, I'm going to click the profile tool to select the profile tool that I want to use. In this case, I'm going to go down here to our iconic tools section, and I'm going to select a 90-degree V-bit and click select. And then the last thing that I need to set as I move down here to the bottom is I need to define what our material thickness is. We haven't really done that yet. So right now our material thickness is set at 0. Pretty sure that's not going to be right. I'm going to change the material thickness to 3/4 of an inch and click OK. I'm going to click calculate now. Now you didn't really see anything happen. I'm going to close the profile window, but if I click on Toolpaths and open up my toolpath operations, if I scroll all the way to the bottom, you'll see that there's an option here to simulate our toolpath. If I click on Simulate Toolpath, you see it gives us an ability to set to define the definition of our, or the detail that it's going to provide us with. I'm going to click on Simulate Toolpath, and you can see that there's our vector created. And if we zoom in, so I can zoom in by using the roller on my mouse, forward and backward. I can push my left and mouse button down simultaneously and drag my image so that I can focus on a specific area. And then if I push my roller down and begin to rotate my part by just moving the roller forward and backward. So that's what the roller push down. So there's three different ways you can manipulate the 3D view. The first one is to push your left and mouse button down simultaneously, and that allows you to pan. The second thing is to use the roller, zooming in and out just by moving the roller forward and backward. And lastly, you push the roller down and begin to move the mouse forward and backward, and it allows you to rotate the part. So we've created our outer border. Now what we want to do is go back and create the toolpath for our text. So let's go back to our 2D view and select our text. And as we just discussed, we want to use a V-bit carving toolpath, because the V-bit carving toolpath is going to allow us to create the geometry as we want to see it. We want to get those square corners. So if I click on the V-bit carving toolpath, and again, just answering the question, start depth at 0. You'll notice in this case I have an option to limit the maximum tool depth. So if I use this, what's going to happen is if the vectors are too far apart where it would machine deeper, maybe deeper than I want, then I can limit it and say, in this case, at 0.125 inches, I don't want you to machine any deeper than that, and it will actually create a flat bottom at that point. And I tend to use that quite a bit. Not only do I find that it looks better, but in most cases it dramatically reduces machining time if I'm not machining projects to a 1/2 inch or 3/4 of an inch of depth. And particularly with the size of the iconic machine being at 15 by 20, I tend to work on smaller projects, and I just find that adding all of that additional depth to a smaller project just really doesn't enhance it much. The other thing that I can click on is to select the carving tool that I want. And again, I'm going to go down to our iconic tools. I'm going to use the same 90-degree V-bit. And now this time I do not need to set our material thickness because we already defined that with the last toolpath that we created. We're going to click on Calculate now, and you can see that it's sort of filled in red the area where we created the toolpath, but it doesn't really tell us what it's going to look like. Now, you'll notice now under the project pane, the word simulation has magically popped up. So because we simulated once, it's now thrown that option up in the project pane. So if I click on simulation, what it does is it opens up all the functions of the simulation. And there are several that you can use. Now, you'll notice in this case, I have the option to reset the simulation. Let me just go to the 3D view for a second. So here you can see we have a 3D simulation of our rectangle. If I click on Reset Simulation, it will disappear. You'll still see the toolpaths that are created for the iconic text, but the 3D simulation is gone. Anytime I make a modification to a simulation, I want to make sure that I reset the simulation and then come over here and simulate all the toolpaths. So as you can see, we simulated our entire toolpath, and now you can see here's our border that we've created, our line of text, iconic CNC. So this is basically the project one. It's basic use of geometry tools. We're going to create the outer rectangle and then the line of text. The last thing that we need to do is actually output this to a toolpath. So we click back on our Toolpaths tab, and in the Toolpath Operations, you see the first option here is called Save Toolpath. We click on Save Toolpath. You see here's our two toolpaths. One's a profile toolpath, one's a V-bit carving toolpath, but they are both using a 90-degree V-bit. I could have 100 toolpaths here. It wouldn't matter. If they were all using a 90-degree V-bit, they would run continuously from one to the next to the next. The software thinking it, or the machine basically treating it all as one machining operation. But in our case, each one of these toolpaths may be for, a different strategy for each one. I'll also click on the Browse button, which gives me the option to change the location where I'm going to save this. So I'm just going to save this project to our desktop, and I will just call this Iconic. And you can see under the machine file format, I have it defaulted to this, what's called post processor, which you can think of in terms of a print driver. Same idea. It's going to basically communicate with the machine using its own language. In this case, we're using one called GTEC millimeters.nc. That's the appropriate one for the iconic machine. And in ArtCAM right now, it's identified as GTEC, which is the manufacturer of our iconic machine. At some point, you may see one pop into the directory. That's called Iconic. That will be something we'll probably see happen in the near future. But it will essentially be the same as this GTEC millimeter.nc. So the .nc is the file output that it's going to create, or the file extension. So we're going to click on that. And you notice that there's several of them there. There's probably hundreds of different post processors, each one being recognized, or each one created for a different type of machine. So we're going to click on Save. And we've saved this file to our desktop, and there's one last step in the process that we have to do with the iconic machine. You don't have to do it, but it's recommended that you do it. We use a program called iPicture. You can see it right here. I'm going to double click on it. And iPicture has two functions. The first function, as you can see on the screen, is it allows me to open an image file, so a photograph, a line drawing. So if I click on Open Image File and say go to my desktop, let's see if I have something here real quick. So this home hardware logo as an example. So here's an image, and you can see there's the size of the image. iPicture allows me to import an image. It can be a line drawing, a logo, a photograph, and it basically uses what we call grayscale conversion and converts this image into machining depth. So in other words, the darker the image, the deeper it machines. The lighter the image, the less it machines. And then it's going to machine it in a raster or linear fashion and basically machine out this entire project so that it reproduces the home hardware logo exactly as you see it. There are some videos on the Iconic website that teach you how to use the functions and features of iPicture to create some really interesting work. For example, you could do something called a lithophane, where you would machine an object, machine on a piece of, say, cast acrylic, and you could take a photograph and reproduce it, and then with some diffused light, create a really interesting project. But more on that later. We'll have other videos that will teach that function. But the other function that the software has is it allows me to open a G-code file, in this case this file that we just created, this iconic file, NC file, and none of the settings or parameters in the software are applying here. All of that information has already been developed and created in the ArtCAM software. So it's just basically asking us to confirm the analysis of the G-code, which we're going to do, and then it says that G-code's been totally analyzed, and we say OK. And basically what's happening is it's taking this G-code file that we created, the NC file, and it's converting it to a G file. And the reason we do that, just so you understand, and it's not required because your machine does recognize an NC file and it will run it. There's a function on the Iconic machine called the border function, which allows you to basically have the tool lift up and basically draw an imaginary box above your material to indicate where this machine is going to, where it's going to machine for this particular project. It eliminates a couple of problems. One of them is the missizing of a piece of material. So I designed a project, in this case 12 by 12, but inadvertently I put a piece of material 8 by 8. And of course that's problematic because the project thinks it's the material is 12 by 12 and it's going to machine outside the border of the material size. The other thing then, actually most common mistake that it avoids, is if I misconfigure the material. So I've got the right size material, but I put it in the wrong way. So I designed a project 12 by 6. But inadvertently, I mount the material in the table 6 by 12. And once again, the machine thinks that the material is 12 by 6, so it's going to machine where there is no material. And sometimes there's a clamp in the way, and that can be a problem. What happens by converting this file, which I just did, you see it says G-code has now been saved, is you see I have two different files. One of them is the NC file, and the other one is the G file. The G file is a kind of a proprietary file format. Essentially, the two files are exactly the same. If I open them both up and sit them side by side. So here on the left is the NC file. Here on the right is the G file. You can see that from this line to this line, they're all exactly the same all the way through the G code. What's added here is this top line of code, and what that does is it's showing the extreme distance. So this is all in metric units, but it's showing the farthest distance on the X the farthest distance on the Y and the farthest distance on the Z for this particular project. And the border function will actually draw a box around that XY coordinate to show you where it's about the machine. So it's kind of a handy function. It also gives you one little extra bonus, and that on your handheld controller, it's going to show you the percentage done. That can only happen with the G file, does not happen with the NC file. But both of them will run off the Iconic machine. So that concludes the first video, which is the basic use of geometry tools. In our next video, we're going to cover off a really interesting function called bitmap to vector conversion. So stay tuned, and we'll catch up with you on the next training video.